Thank you very much, Bhupinder. And next, we begin with the next session. The session is called Little BIM, Big BIM, Civil BIM, FM BIM. We will see 3 different case studies. We will see case studies from one campus of one university here in Barcelona. We will see how it can be managed metro station for next 10 years in Sweden. And we will see also some infrastructures made by one engineering firm in Portugal. But I would like to say what we will be talking now, because Bhupinder has been talking about a digital twin. And the thing is, I don't know if you can see which is more or less the thing, no? So this is the problem of BIM. The thing is that you can have a 3D model, you can build a 3D model, but you cannot interact with this 3D model. I tried to put him in my home, and my wife discovered him. So the thing, I think, is a nice illustration of what is happening right now in BIM. No? So we can have a real model in 3D. We have this possibility of interaction with it. But in fact, we cannot really take some fruits and some profits for this. So the next 2 sessions are about this, how we are building and how we are saying to the building companies how to implement BIM, because this is really necessary. But all of us, we have to be focused, as Bhupinder Singh has said, to the owner, and also how the people will interact with the thing that will manage in the future. In fact, I probably think this guy has to be with me the next years. So we would need this interaction. I will introduce now Kajetil Toning. He's, excuse me. I have to introduce Pedro Fernández Alén. He is the Secretary General from CNC, the Confederación Nacional de Constructores, por favor. And he will invite the next lecturers. Thank you very much. I take myself.
Bueno, difícil tras esta...
Well, it's difficult after the previous presentations to say something that can impress all of you. Also, I'm sorry for paper beans, because we say that paper needs to disappear, right? Anyway, I would like to thank the CATEP, also Building Smart and the BIM Academy for the great organization. And first of all, I would like to apologize because I will be moderating in this session. I'm not a moderated person, actually, so it may not be a good fit. I could not be here, but it's fine. The CNC is the National Confederation of Construction, and it comprises all the organizations, small companies, large companies, product producers, service providers for the construction sector, and that's a big melting pot. We are all together. That means that BIM has somehow revolutionized our organizations, has been a revolution for companies, and we have needed to have a shift. I like to start my presentation saying that the construction sector is based on the general agreement of the construction sector. Second, the basis of the construction sector, that is based in BIM, and that could be the university of the construction sector, and is actually the one that grants the training needed. And then the third pillar is the subcontracting law that has aimed to put some order in the jungle of the construction sector. I have a degree in law, and I will try to give a brief description of the situation we have nowadays. We are moving towards digitalization, and that is changing the country, it's changing society, and it's also changing labor relations. That's from an internal point of view. We need to rethink the change that we all need to undertake, because technology has caused disruption. You know, when we are bored, we take our cell phones. Some people have taken that since the moment I started talking. Sorry about that. But then we also need to be aware about the role of globalization and how it has created new needs, new rules, and it has created also the facility management, for example. It has created the needs that we will hear about today because it has caused real needs. But again, at the same time, we need to see that there are new works, new professions, and new processes. It is said that 40% of the current jobs we have today won't exist within 20 years. That's a strong affirmation. Work is not a constant anymore. Many of us who were here know Naranjito from the world champion in 1982. But times change, and there are new jobs, new professions. Chema, for example, told me he's a quantity surveyor, but I'm sure when he studied, he really didn't go through everything, all the tools he's using nowadays. And one of the important things I want to mention is that the professional career is not a straight line, but a continuum. Our parents worked in the same job and the same company for all their lives, but now things are different. It's not a straight line. We need to deviate. Maybe there will be interruptions. Maybe we'll need to have some stops in our professional career in order to move forward. There are new models, new training, new education. And we need to keep that into mind. If BIM is studied in universities now, we hope it is implemented within 10 years, because the current students will be done with their studies within 4 or 5 years, and then they will need some 4 or 5 years to start working and start using these BIM technologies. So we see there's a cultural shift, a professional shift, and also we are changing our flexibility. We are creating new needs, new models, and new businesses. So whoever gets there faster will be the one that will be able to hit the pot. I like to give an example. Recently, we had a survey from a property website, Infocasa. In the past, 3 out of 10, one wanted to buy a house, 2 wanted to rent a house. Now it's the opposite. If you ask young people, they will tell you they want to buy a house. But then if you ask them, do you have the priority of buying a house within the next few years? If you ask young people from 20 to 30, they will say no, but they will have other priorities. They want to have a light and nice bike, and they want a nice cell phone. We are creating a broke generation that is not that interested in construction anymore. Things are changing. Actually, the last Fotocasa survey states that 88% of people who rent a house do not want to have a rental contract longer than 1 year. In the past, we wanted to have long contracts, but now 88% do not want it. That's why there are other platforms such as Airbnb that are appearing. Society is changing, we need to know that. And also, I think that, as we said earlier today, we need to have institutional leadership, but also taking into account that circumstances change, we also need to change. Keynes actually said that if circumstances change, we need to change our opinions and we need to start changing ourselves. Whoever only looks at the past and the present will miss the future. That's what Kennedy said. That's why we will talk about the practical applications of what we are saying. And we will see what these practical situations mean today. I give the floor to Daniel Ansello from Sueco and Roberto Alberola.
Hello, hello. Can you hear me? Yeah, good. Well, thank you a lot for being here today. It's a great opportunity to present the metro extension that we are working with in Stockholm. It's a cooperation between a joint venture between TIPSA and Sueco. Today, we will look into a couple of different things here. I will just do a flyover, show you the project, continue with how to get connected in these kind of projects, and also move forward with the way we are working with integrated design. Talk about the reality modeling. You can hear about what's possible to do. Here, it's what you can do. So it's something we started with, I think it's like more than 2 years ago. So we will show you something about that today, even though it will be a quick version of this presentation. Estocolmo is one of the fastest growing cities in Europe. The population increases and many new people come to Stockholm. The increase is about 40,000 people each year, and the transport systems need to be upgraded. Now, at last, the metro station will be upgraded. Today, there are 100 stations, and 10 years from now, there will be 10 more, and they are needed. Flying over the castle of Stockholm, we will turn around, go to the part we are working with. Because this part is, this is the existing blue line today. They have the end station here. The entire tunnels run through rock, and there's a deep crack under the Baltic Sea, where the construction will take place. Moving forward, we'll see the Sofia station, which is more than 100 meters underground. It's one of the deepest stations in the world. Moving forward, we'll have a branch here. Well, one goes to Söderort and one goes to the Nacka municipality. Starting with the Nacka municipality, we will have, you can see the Hammarby Canal, which has entrances on both sides of the canal. Moving forward, we will see the Sickla station, which is really very important due to shopping malls and connection points for public transport. Moving forward, we'll see Järla and the end station here, Nacka, which is extremely important on the south side of Stockholm. This is a visualization we have created with something called metal luminarity. We have federated the models, of course, and we have been working with contact capture and things like that. You can see it in the previous session here, what's able to be done. And this is quite powerful in the communication, of course, showing what we are, where we are going. This is the other branch. You can see we were flying over Gullmarsplan, which is a new station under the existing one, Slakthuset, and the connection point to Sockenplan, to the existing one. And here we can see a top perspective. You can see the size of this project. This is one part of this project, the metro extension. Here is the traditional map, and quite soon you can see the schematically metro map that we have. So it's a quite central part that now it will be extended. The client in this have a clear vision of BIM. It's focusing very much on facility management, all the way to facility management, the life cycle perspective, and so on. And it's, of course, a long way to go, but it's a very clear picture of where we are aiming. And this is a public organization. So the demands is very clear. And when we will go into tender phase, we will also have the models will be in the contract, and will be a higher legal status on models compared to drawings, which is not usually the case in all countries. In the assignment for Sweco and Tipsa, we are working very much with VDC. BIM is great. It's a strong component, the technology of BIM and what we can do, but it's important to see more than that, since you need to work a lot with the way we're working, how to go integrated in daily work, how to go integrated in something called ICE sessions to a more effective decision-making process, and how to work with management on different levels, because they need to drive this. It can't be the single one in the corner. the guy here that thinks that CAD and things like that is interesting. This is something for everybody. That's important. In this project, we have approximately 1,000 people right now working between 7 countries. There will be more since we will go now from the more stage called systemhandling, which is like preliminary design into detailed design. So it will be even bigger the upcoming years. This is the way we have been working right now. We have been connected teams, even though they're sitting in different offices and countries and so on. We have connected them, very important, one single point of truth. And that has been very powerful. We haven't been able to do this project without this setup, because then we can't manage it. It's like impossible. We have customized the way we're working. In this case, it's project-wise, as you can see. We have customized it due to the organization, due to the requirement, and it follows the quality plan in every step, and that's important. And we have a client integration in something called shared state, so they can see what's happening all the time, since transparency and cooperation is important in the project. We are also getting more into connecting team to each other, so we can have multiply of ICE sessions ongoing in the biggest office we have included in this project. So we are connecting them in different ways. Of course, we have the information stored, and we can integrate tools into one single point of truth. We have, on top of that, we have a communication layer at the moment for like issue resolution and management. And we also are using the normal ways of communicating. And that's something people are like stop doing. When they're like going into these kind of tools, they're not calling each other anymore. They are not like talking with each other. So we are like we're like losing the easiest things. And that's something to keep in mind. It's good to still have this normal conversation as well. It doesn't like will do the job on their own, even though we think it's like that. So that's important. Co-located, go online, connected teams.
Integrated design. With these words, we simply mean every team working coordinated in the same way. The information exchange is managed inside a CDE, and the design updates are available to all teams daily. The design advances by a continuous loop between work and previous states, and when reaching predefined milestones, it's pushed further within the workflow. We have involved many design tools, and the key point is how they work inside ProjectWise. Some of them are fully integrated as Bentley tools, but also Revit and Civil 3D have a good integration in ProjectWise. We have achieved that. And some of them, like Tekla, we have been able to set up routines that upload the outcomes automatically. The coordination process continues from the daily loop of work in progress states, and weekly the files pass through design and quality checks before going into shared state. Then every discipline model is gathered to be combined in a coordination model that serves as the basis for design review in meetings and coordination review. We are sharing these models in meetings involving relevant teams from all our offices, like you said. The way the design is communicated to all teams is through the use of these coordination models. These federated models that combine others are updated on a weekly basis. We are sharing them in several ways. 4 of them, you can see them here, to be able to meet different needs inside ProjectWise or with a tool called Navigator in the web interface that ProjectWise provides. And also the mobile devices are used daily to consult the updated design. BIM coordination takes place inside a cloud-based communication platform that manages the whole process. Class checks are made by coordination teams to search for collisions between specific parts of the design. The conflict can then be classified and assigned to relevant teams, and all issues can be tracked so the design evolves free of major clashes. Metrics allow us to measure the performance. A little bit more about reality modeling that was earlier. This is what we have already done and achieved, I think it's 2 years ago. This is an example of how we have captured and created reality model in a city environment. And this is one of the entrances areas of Sofia Station. The process is 3 steps: acquisition, by capturing data by drones, then processing the material, and then the model can be viewed and used in different modes. Realistic mesh, point cloud, or wireframe. We have used this data to visualize the existing conditions in the city of Stockholm and the Nacka municipality. It helps to understand where and how the allocation of the engineering design fits into the existing environment. It's very easy to use and it has given us the opportunity to present a combined model that includes up-to-date design and real-world conditions together. This material has been used both internally and in communication with the client. One of the goals in the project is to use object-based design to support 4D and 5D. The data-rich models contain information in the objects at the required level. This information helps us to integrate the design with the production planning and cost estimation. We can drive the divisions on the production time plan by the outcomes from parametric rock tunnel design. You can see here. We can locate quantities and estimate cost easier. And also we can upload directly the IFCs into the estimation program. The client requirements regarding deliverables include a wide variety of documents. 3D models in native and delivery formats, 2D drawings and graphical views, and bill of quantities and information deliveries. The strategy is to extract from native design models. This is what we have done so far, the first phase. And this is the next phase. We have just delivered system handling, and we are planning the big handling, which is a detailed design phase, in which we will be involved, I would say, 2-3 more years. Thank you very much. First, we want to say thanks to all the rest of the team, more than 500 professionals that have been working with us. We are only the voices of that story. We know some of them are here, and I'm sure they are connected. It feels very good to be part of this huge team. And thanks for the organization and to all of you for your attention. It's a pleasure. Thank you.
Ahora le doy la palabra.
So now I give the floor to Chema Diaz. He's the Chief of Technical Services and Infrastructures of the International University of Catalonia. Well, thank you. Actually, it's quite nice to be up here talking to you. Can you hear me well? Well, before my presentation appears on screen, I will introduce myself. I am Chema Diaz. I'm the Chief of Technical Services at the International University of Catalonia. And basically, I am in charge of all integrated services comprised in the infrastructure, both technical and maintenance, and services which range from even cleaning, which is actually quite related to our services, and also gardening, everything. Well, the translation into English would be the infrastructure and BIM manager. Well, what do we do, actually? It's quite a humble university, 50,000 square meters. It's in Sant Cugat, on the outskirts of Barcelona. It has 3 different campuses, and it offers common degrees such as law and architecture and so on. I started working there 7 years ago, and I saw a lot of CAD plans, Excel files, but when it was time to get into action, for instance, in maintenance tasks, we realized that this information was untrue because some buildings had been extended and some plans were contradictory to each other. So there was not a final version which corresponded to reality, and facility managers in companies and public administration, it happens quite often that we cannot rely on the information on print and on paper. From 2015, the university had implemented communication and information technologies. So we decided that something had to be done. And we started to implement BIM in order to automatize maintenance from all the services and facility management, transfers, general services, occupation. And that's how we started. My colleagues, actually, Daniel and Roberto, talk about the connection between technical equipments. But once you are in the organization, the collaboration must be created among different departments, because I require not only information related to infrastructure, but also in terms of occupation, also the staff, the departments who employ actually the staff, again, occupation and the use of buildings, etc., etc. On the slide, you can see all the interconnection that we had to carry out together with the different stakeholders in the university. Economical management, all the assets and the works that have a lifetime must have an investment plan. And ultimately, what I wanted to say, and something that I don't want to forget, since I don't have much time, the collaborative process helps to create a unique database. A unique database which is true.
Y sigo adelante. Entonces aquí está.
Ferran Falcó approached this cultural shift when talking about interdepartment collaboration, and I think that's absolutely necessary and fundamental. And we elaborated an EIR. There were some consultation works and previous works in order to see what did we want to achieve with this database, what kind of data were needed to manage the different facilities and at which levels, ranging from the management down to the operations through technical and so on. So how was this technical information to be used? Only the data that it's necessary. So that would be the definition. Let's not include more information than needed. So only to take into consideration this data that we can manage and we can handle and we can update. If something must be changed, then the database must comprise how this or that part must be replaced. If you have to increase your stock, then in your database you have to comprise this, the system to renovate your stock. And Well, in our case, to manage the assets, we use this information. But for you to have an idea of what kind of data the client needs, I'm sure that most of you are in charge of BIM implementation projects and must be aware that at the end of the day, the owner must reach the goal with an added value. And you have to define what's needed and not needed. Everything you don't need, either you take it out, or you mark it in gray, or you comment that it's not necessary. But you have to define what you actually need or not, because it will make your life easier. Well, now I'm going to explain this a little bit. That will be the parameters I needed. I reduced them to 30. I think you cannot see it very well, but occupation management, assets management, and so on. So the different uses of my departments. That would be the naming and the description of the parameter. In this case, it was Archibus. And then the naming and the description of the parameter in BIM. So that will be the interrelationship in Revit. And what for? In order to manage maintenance, items replacements, and different uses. Then the CAFM parameter, I think that will be the one in Archibus. So this information, the one on the left, is the same as the one in the right. The next step would be, from which assets do I require which parameters? Sure, I won't need all the information regarding all assets. So in this case, basically, to classify, what do I need? So as we can see here, like fire extinguishers, refrigerators, and so on. So classify the assets and define the parameters that we require. That belongs to the previous work. In our project, we had in the first place a strategic meeting to elaborate the execution plan, to define what we wanted, and then to gather the information, data gathering. Mostly we gather all this information on site. Actually, there were a group of students who had taken a 30-hour course on Revit, so they helped us, and they started working with this. And in some cases, we had some 3D scannings. For instance, this area here would be a 3D scanning, because it's very difficult to extract information just by sight. The third place, the modeling. That was the largest stage, the longest actually, a whole summer. Then dump an integration of the data on the CAFM. So we had to integrate all this information in the facilities management system. And it may seem pretty obvious, but if you have skipped some previous steps, then this dumping and integration will be quite complex and difficult. I'm running out of time. I'm sorry. I'm quite behind. And finally, the integration of the rest of the database, preventive maintenance, database, stock database. All this information is not included in the BIM model. Could be there. But when I had to take a decision, I decided to go with a method that included this information after consulting with the modeling company, and so I included all this information that was known to the companies who had to work with it. And finally, to set the team, and that's fundamental. Each member of the team was or shared what was the reason to collect this or that data, what was its use, and so on. Because if you want an alive database, there must be people behind it. People must realize the added value provided by the fact that you are aware of the information. And that's not easy at all. I work with a colleague of mine, Miguel Angel. He's a 55-year-old man. He's never worked with tablets before, and he just got one. And now he's realizing of the added value of the fact that if, a light bulb must be replaced, the tablet knows exactly where this light bulb is located. So he goes, picks a new light bulb, and replaces it. He doesn't have to go up the ladder and see what kind of light bulb, the type, the model, see if it fits it or not. He has all this information in his tablet, and processes that would take about 3 weeks can be reduced to just 3 days. So there are so many improvements that these systems allows. Well, where are we now currently? We are already applying corrective maintenance measures, also preventive maintenance, supplies plan that we do together with the economical management department. We can tell them more precisely how much money do we need for all the stock that's going to be used, and then transfer management and the future, which is actually already the present, because we are already working with BMS from automation of all facilities and infrastructures. So I'm being kicked out, actually, so I will be closing my speech. Some images I want to provide you with, but what matters is not the information, is the data that you can see here on the right, the type and so on. That's quite nice to see where the pipelines go through, the wires and so on. So to have the data and that this data corresponds to reality. So that's where I work. That's my operation platform. I see all reports and all issues, and I can follow the current state of the operation, then the map of the different spaces or the different rooms in the building. So I have also here the information of all the staff working in every room, and I can see if a room is used or not, and at what times. And so that would be it. Thank you very much for your attention. I hope it was helpful.
Y ahora, en tercer lugar,
So in the third place, we have José Carlos Lino. He's not on the program, but he belongs to one of the best BIM consultants companies in Portugal, and we are happy to have him here.
Good morning, everybody. Thank you very much to the organization, to Ignazi, about this wonderful summit and the way it has been taken by them. Congrats. As has been said by Pedro, my name is not in the program. I'm sorry for that, but you can find my face in the short presentation inside your folder. There is a booklet about Global BIM Management Certification Program by Ziggurat, where I have the pleasure to be one of the lecturers there, so you can find it there. Well, because we have very short time to present, I am sorry I had twice the time, so I need to shrink to half, so don't get sick with the images that I will pass really fast, but there is life after BIM for building, and this is what we are talking this morning here. Several guys haven't talked about infra BIM, about civil BIM, about road BIM. So civil engineering is quite an important approach to BIM because we deal mainly with major public and large investments, firstly. Secondly, we have specialized programs that are used to apply on those kind of construction types. So it is very important that we anticipate the need of those structures to operate and to maintain in the future. On counterpart, the requirements and deliverables are specific, so we need software approach to deal with it, and we have a large number of people, large number of profiles that are doing the traditional way, and we need to change it. So we have here some challenges. And I will go fast to 4 small practical cases that will talk by themselves. That's what I think that is important. This firstly is an industrial facility project in Bolivia. So you can think that it could be a building, but this is totally an industrial building. You don't need an architect, or you don't have an architect. Sometimes you have, of course, architects to manage the space, to manage something. But here we have dealt with an international team, working international, that were from Spain, Portugal, Mexico, Ecuador, Peru, and Bolivia. Nowadays, this is the usual kind of work that we have. Each one at home, and dealing with a collaborative platform and working all together. Simultaneous modeling of all of this, and also taking account the logistics and assembly part. The logistics and assembly part are very important in industrial projects because you don't have sometimes space on site. You need to prepare everything in advance. This was a factory to make cement. It was in Bolivia, and we had the need to modulate the rebar, the steel, but all of them together. And this was a need asked by the owner. The owner has experience on this and was mandated by the owner. And it proved to be right because the clash between all of these kind of structural engineering structures come to found things that could be problems on site. And also, we had developed something to present to people that are not so skilled in BIM. It's in the right down corner, to present it in a reality-based way. But this kind of, as you can be a global site, this kind of constructions has these types of connections of several organs that are linked together. So you need to have take account of the linking of them. Where are they located on? The second one is a wastewater treatment plant. This plant was in Portugal. It's a normal plant, a medium-sized plant. And of course, when you deal with this, namely in a bid-build contract type with a contractor, you have a tendering phase where you have less than 1 month to make a proposition, okay? So in that type, you need to make a very fast conceptual analysis. You need to produce visualization that will help your proposal in marketing, of course, and you will need to take a quantitative cost that will jail you because it will need to be very accurate, but when you do fast, you can have problems with accuracy. So the first thing that when you got the project is to verify in the execution phase, is to verify the quantity takeoff, to verify, to adjust the planning, to optimize the solutions. As you can see here, you have a straight section. Here you have the section optimized because of the concreting and so. And also to deal with the phasing, all the phases that sometimes are linked to the project. And I put this here on purpose. This is visualization. In water treatment, you may see that the quality of this visualization is very important. This is not BIM Hollywood, okay? This is taking care of what BIM has to give to us. And in this case, we use it on the tendering phase as marketing, as I said, but during the construction and also within the operation, okay? People want to see the type of equipment that we'll have to handle. And here you can find a global model, all connected, that are really a virtual design and construction of the whole process, not only a organ or not only one piece of BIM, a model. Bridge information modeling. Civil engineer deals with bridges. I can name it here, of course. I could name it tunnels and other types of structures. But this kind of bridge, you need to deal it on almost every roads and train also. This bridge was already designed, and it was made a pilot case trying to be how it could be from BIM against traditional. So we have this type of drawings, and they've made lots of special modelings. And bridge information modeling has a major problem that has the same in dams, that is, you have special geometry issues like shapes that are not, that need to be shaped. Sorry for the pleonasm, but for instance, these three slabs, each one of it has different and variable height, for instance, and you can cut probably the bridge on a vertical slash or on a perpendicular slash to the alignment. There are issues, and of course, the bridges tend to be variable, and sometimes in curve and going around, but all of this with the need of rebar detailing most of the time and pre-stress detailing also comes with a huge challenge to make bridges. And also, of course, the planning. The planning is all in the bridge, okay? So, and of course, the way the bridge is built, any kind of bridge is built, needs to have the model interconnected, okay? And also the team communication that was ready to prepare also a model of monitoring. This is a very important thing, that the bridges are starting to have BIM models that have all the sensors and all the monitors that the monitoring that the bridge has to have and to deal with. The last one is a highway in Algeria, but I will split it in two highways. The first one is the preliminary phase. There is a session about infrastructure, so I won't take much time on that. There will be experts talking about this, but we have a problem in BIM and mainly in highways also that can be this preliminary phase. This preliminary phase, you don't have really everything shift, everything drawn. So you need to take choices. In this case, with Teixeira Duarte, the choice was what are the intended users that you want to be in the model? What are the requirements? And so we will decide what to model and what to deliverable, okay? And the deliverables in this phase, in this kind of owner, of a contractor, it was for a contractor in a bid-build approach, was only a model, a video, and operational report in this preliminary phase. What happens? Of course, interconnection and coordination between the teams. I can take 2 minutes more. Okay. Interconnection between the teams. Of course, understanding the tendril elements, but lots of times bridging the gap between the execution project and what we have. And you need to use it using our standards, using a very strict level of development or level of detail, of level of information, whatever you want, and wherever, in which country you are, whatever level you want, and also parametric modeling, for instance, for viaducts. In this kind of roads, you can earn money and time by making parametric modeling and having phasing on your on viaducts. Of course, the clarification request should be integrated in the model, should be as well as the quality assurance of the model, assessment, pardon. The model should be assessed, its quality within the model. And this highway was 25 kilometers with 14 structures, and you have here several types of, I am out of time, so I will finish only to show you this small movie, and I'm just 1 minute more, and I'm just finished, okay? That is, as you can see, it's in a preliminary phase, but you can mount a lot in this phase with this type. And on last phase, I will take this example on Brazil, with our partners Eficácia, and the engineer Gustavo Simões, that is a highway that was mainly a cultural problem. They needed, it was on the coast with a land expropriation issues, and they needed to deal with the population, with the local authorities, and with 1 month to do it. So they have to capture the reality, as we have already seen, and we have to speed up all this type of issues. Of course, the line design was a starting point, trying to reach some alignments. Then they come, this is the alignment, and they come to the 3D designs. The unleveled, the viaducts, the different levels of connection, and this to end with a video that allowed the population to understand exactly what it intends to be done, and appreciating the project by all, and even capturing the reality. What you are seeing, it's a cloud point-based acquired. It's not a photo, it's a cloud point acquired next to our model that, of course, have these dynamic elements. And that's all. Thank you very much.